All right, so now let's work some problems based on what we just have studied. So we're going to say f of x is equal to x minus 3 over x squared minus 4x plus 3, and we're supposed to describe the behavior of f at each zero of the denominator. So we're going to use positive and negative infinity where appropriate and identify all vertical asymptotes. All right, so what we need to do is we need to think about what does f of x equal if we factor it. And so, oops. What we have is right, not move, x minus 3 over, and then if we have that, that's going to be x minus 3, x minus 1. And if we multiply that back out, that's a plus 3, and then it's going to be a minus 4. So that should work, okay? So our zeros then are going to be x is equal to 1 and x equals a 3. All right, and so where the numerator is going to be having a vertical asymptote is going to be where if we plug this in, we don't get equal to 0. So if we plug in a 1, that's going to give us a minus 2. So that means we probably have a vertical asymptote there. But if we plug in a 3, that's going to give us 0, and that's not going to give us a vertical asymptote. So because that should be the vertical asymptote, what we have to do is we're going to have to do our tables, and we'll have the x minus 3 over x minus 3, x minus 1, and we're going to go around 1. So what we're thinking about here, if we think about it, here's our 1. We're saying that's going to be our vertical asymptote. So we have to come from the left and from the right. And so if we come from the right first, positive things first there, 1.1, then we'll have 1.01, 1.001, 1.0001, and we just plug that into our equation. So if we plug in 1.1, we get 10. And if we plug in 1.01, we get 100. And then we get 1,000. And then we get 10,000. And then if we have 1.00001, we get 100,000. And what happens is it just keeps getting larger. So it's going to positive infinity. Now, if we plug in x into the same thing, and this time we're going to be lazy and just write f of x, and we say we have 0.9, 0.99, 0.999, 0.9999, and 0.99999. Then what do we get? Well, this one we get a minus 10, and then a minus 100, minus 1,000, minus 10,000, minus 100,000, and so on. And it looks like it's going to negative infinity. Okay. And so we can say then that the limit, well, I guess we can write it in here. The limit at, oh, maybe not, up here, we'll go, where did it go? Where's my mouse? All right. So then we say the limit of f of x as x approaches 1 from the right is going to be equal to what? Well, we said that's positive infinity, and the limit of f of x as x approaches 1 from the left is going to be equal to negative infinity. Okay, and that's a vertical asymptote. So that's going to be where that is. And then what we can do is we said that this one's not going to be a vertical asymptote. And so what we have to do algebraically then is we have to simplify that. And when we simplify it, guess what? If we cancel those out, we just get the 1 over x minus 1. Okay. And now we can do the limit as x approaches 3 of 1 over x minus 1. And that's going to be what? Well, that's going to be 1 over 3 minus 1, or 1/2. Okay. And so that's what the value is going to be there. And so as we approach 3, so it's going to be out here a little bit further, it's going to be at about a half. Okay. And if we graph these, what this looks like, we kind of saw in the last thing, it's going to be something like this and something like this. And so about a half is where it's going to hit at 3. And this is going to negative infinity on the left side, which is this side over here. And it's going to positive infinity on this side, which is what we show here. Okay, and so that kind of shows what we've seen, and we had to do this reduction to be able to actually find this limit, because we couldn't do it before, because if we did it before, we get 0 over 0, which is the determinant, and that's why we had to cancel and reduce as much as we could. Okay. All right, what about this one? So again, we have a different value for f of x. And again, we're supposed to describe each of the zeros of the denominator. And so basically what we're going to have to do is we have to think about this. Well, what are the zeros? Well, the zero is going to be x is equal to what? A minus 3. Okay. Well, in this case, there's nothing we can cancel. And so that has to be 0, because if we plug in a minus 3 up at the top, that's not going to be a 0 there. And so that's going to be a vertical asymptote. And we need to now plug in our x's and our f of x and our x and our f of x. And so we'll go to negative 3. So it'll be negative 3.1, say, negative 3.01, negative 3.001, and negative 3.0001. And over here, we're going to go negative 2.9, negative 2.99, negative 2.999, negative 2.9999. Oops, 9. And if we plug that in, what do we get? Well, this one we're going to get a minus 410. Then we're going to get a minus 40100. And then we're going to get a minus 401,000. And then we're going to get a huge number. It's just going to get very large. And so this is going to negative infinity, it looks like. Now, if we plug it in here, what do we get? Well, that's going to be a negative 390. Then that's going to be a negative 39900, negative 3999000, negative 312341234, and we notice that that's going to negative infinity as well. So the limit as x approaches 3 from the left of f of x, again, we're not going to write it all out, is going to be negative infinity. And here, the limit of f of x as x approaches x from the right, yeah, this time right, is going to be negative infinity as well. Okay, so those two we can see are equal, the both going to negative infinity. And so that means at our vertical asymptote, which is somewhere over here, negative 3, they're both coming down to negative infinity. They're both going that way. And if we actually graph this, then what happens is we get something like that. Again, it's a rough sketch, but you can plug it in your calculator and see what it looks like. But they're both going down to negative infinity. Okay. All right. So let's pause there and we'll go some more definitions.